Hi, I'm Iwe. I'm a PhD student in Text-to-Knowledge group in Ghent University. Here I will talk about our paper, Recipe Instruction Semantics Corpus. In short, we also call it RESEC. In our NLP community, there is a long pursuit of letting machines understand procedure texts. Everyone should be familiar with procedure information. It exists in multiple media and modalities, like texts or images. For example, you might have asked for help in the WikiHow website, or read a new recipe to make a delicious dish, or even follow a menu to assemble a fancy logo car. Well, in our paper, we focus on extracting information from recipes, which are a typical document of procedural texts. On the other hand, we also hope to facilitate possible applications, for instance, a task-oriented conversational agent that can instruct people to cook without reading any recipes. For a machine, a recipe document is neither structured nor readable, so first we need to detect and structuralize the information hidden in the recipes. For example, the ingredients, actions, duration, and so on. Then we convert the information into a structured format so any machine can understand what a recipe really means. With the structured data and the machine learning algorithm, we will be able to train an agent system. The agent is designed to provide instructions for a user to cook a meal, a dessert, or whatever he or she likes. Additionally, this bot can also answer questions asked by the user when he or she has trouble in cooking something. For now, we have constructed a recipe corpus from which we could extract language information like the entities and the relations. In our corpus, we annotate 260 recipes from the curd and simmer project. Basically, we provide two layers of annotations. One layer is an entity layer. The other one is a relation layer. Different from previous work like curd and simmer, we do not rely on the ingredient list. Instead, we directly extract food entities and also the intermediate products from recipe instructions. We also address another interesting issue in recipes, that is zero anaphora. Zero anaphora denotes the noun phrases which do not have explicit mention in texts. In particular, we focus on the objects after verbs in recipe texts. You can see two examples in the right figure. We manually add the anaphora phrases in the brackets. For example, in step 3, the crab mixture after bake actually refers to the products from step 2. The baked crab after serve is a result from bake action. We think zero anaphora may impede the machine to understand recipe language, so we propose two methods to resolve it. First, we try to identify those zero anaphora verbs. Then we also try to generate the omitted objects after verbs. So in a nutshell, we need to solve two tasks. One is information extraction on entity and relation layers. Another task is to generate a textual description of the missing objects in zero anaphoras. We developed two models for the two tasks in terms of their independency with each other. First, we use a span-based model in which we jointly train two modules, entity recognition and relation identification. To feed the data into the model, first we embed all the tokens in a recipe and pass the embeddings to a bidirectional LSTM encoder. Then we have a sequence of token representation vectors. By concatenating the start and end point of each span, that is enumerated from the sentence, we obtain the span representations. Then we pass the span representations into two independent feed-forward networks, which compute scores of entity recognition and relation identification, respectively. The training objective is a weighted sum of the two losses. For the second task, regarding the zero anaphora, we use a sequence-to-sequence attention model to generate phrases of the missing objects. Here I list the experiment results from our extraction model. The table on the right shows that our model does quite well, as it gets 89.8 and 65.5 for entity recognition and relation extraction, respectively. Our model also shows good ability in terms of detecting zero anaphora verb, as you can see in the blue box. In addition, we find that using BERT to embed tokens enhances the performance, especially when we use a large BERT model. But if we take a detailed look into each entity and relation, we find that our model failed to detect specific relations due to their low occurring frequencies in the dataset. For example, the relations in the red boxes have scores less than 20%. For the generation task, our model fails in most cases, as it always predicts mixture or chicken as an anaphora description. We think the small size of our training data is a main reason for the poor performance. So in this paper, we developed ReSeq, a new dataset for extracting structured information from recipes. Our annotation includes 4 aspects, and we mainly focus on recipe-related entities and generic relations connecting these entities. We also report our progress of 2 baseline models. For the future, we plan to make the dataset larger and finer grained. We also would like to investigate how it can be used to build procedure-based conversational agents. That's all about our current research. Thanks.